All right, welcome to the Explainer. Today, we're going to climb the ladder of artificial intelligence. We're going to break down the 5 different types of AI agents, starting with the absolute basics and leveling all the way up to the ones that are, well, kind of brilliant.
I mean, you've probably seen this everywhere, right? AI agents are the hot topic. It feels like there's a new breakthrough announced every single week. They're promising to automate these super complex tasks, stuff we thought only humans could handle. And that promise, yeah, it's changing everything. But here's the thing, underneath all that hype, there's this really fascinating hierarchy of intelligence. And look, knowing the difference between these agents is the key to understanding what they can actually do versus what people are just promising they can do. So let's get into it. Okay, so the agent revolution. Before we can get to the different levels, we first have to get a handle on the basic building blocks that all of these agents share. Okay, so think of it like this. The agent itself, that's the brain. The environment is just, well, the world it operates in. The sensors are its senses, a camera, a microphone, whatever, and they gather all this information, which we call percepts. Then you've got the actuators, which are basically its hands or its limbs. They're the parts that actually perform actions and change stuff in the environment. All right, on to level 1, react and remember. We're going to start our journey here with the most basic agent you can possibly imagine, and then we're going to give it its first big upgrade, a memory. So the simple Reflex agent, this is the simplest one of the bunch for sure. It operates on pure, simple, if this, then that logic. It has zero memory of the past and absolutely no plans for the future. It just sees something and reacts. That's it. A classic thermostat is the perfect example. Its sensor feels the temperature right now. The rule is dead simple. If the room is below, say, 18 degrees, then the actuator kicks on the heat. It has no idea it was cold 5 minutes ago. It only knows what's happening this very second. And that right there, that lack of memory, is its biggest weakness. It can make the same mistake again and again. So this brings us to our first real level up. What happens when we give this simple agent a memory? Well, you get a model-based reflex agent. The huge upgrade here is this idea of an internal model of the world. And really, that's just a fancy way of saying it has a memory. This model helps the agent keep track of how the world is changing, and it even lets it understand stuff about the environment that it can't, literally see right at this moment. Think about a robotic vacuum cleaner. That's a perfect example. It builds this little map of your room in its head, right? It remembers where it's already cleaned and where that pesky table leg is. It's not just reacting to a dust bunny it sees anymore. It's using its memory, its model, to clean the whole room without bumping into things over and over. Okay, so we've gone from just reacting to actually remembering. Now for level 2, aim and evaluate. For our next big level up, we're giving these agents the ability to think about the future. And this is where things start to get really, really smart. This one, the goal-based agent, is a total game changer. Instead of just blindly following if-then rules, it has a goal. It actually uses its internal model to play out different scenarios in its head, to simulate actions and predict what will happen. And then it chooses the path that'll get it to its goal. Yep, it's a planner. So it stops asking, what does my rule say, and starts asking, what action will get me closer to my goal? Think about a self-driving car. Its main goal is to get you to your destination. It's constantly simulating the future. If I turn left here, what happens? If I stay in this lane, am I on the right track? It's not just reacting to the brake lights in front of it. It's actively planning the entire route. But okay, what if there are a bunch of different ways to reach that goal, right? Some might be fast, but maybe a little risky. Others could be slow, but super safe. That's where our next upgrade comes in. A utility-based agent doesn't just find a way to the goal, it finds the best way. It does this by giving each possible outcome a utility score, which is basically just a happiness score. Let's look at the drone example. A goal-based drone, its goal is just deliver the package. Any old route will do, as long as it gets there. But a utility-based drone, now that's an optimizer. It's weighing everything, speed, safety, how much battery it'll use, to find the absolute best route with the highest happiness score. It doesn't want just any delivery, it wants the perfect delivery. Okay, get ready for the final and most powerful level up of all. Level 3, learn and improve. So we've gone from reacting to remembering to planning and then to optimizing. What's possibly left? Well, It's the ability to learn and get better completely on its own. This is the top of the pyramid. A learning agent isn't just programmed with a fixed set of rules or goals. Nope, it starts with a basic framework, and then it improves its own performance through trial and error. It actually learns from what it does right, and maybe more importantly, from what it does wrong. So how does it actually do that? It's all about this really powerful feedback loop. You've got 4 parts. First, the performance element. That's the part that acts, that makes a move. Then, the critic steps in and judges that move. Was it good or bad? Third, the learning element. Takes that feedback and updates the whole strategy. And finally, the problem generator gets creative and suggests brand new things to try, pushing the agent to experiment. The classic example here is an AI chessbot. Think about it. It plays a game. The critic tells it, hey, you won, or nope, you lost. The learning element then chews on all that data to adjust its strategy for the future. The problem generator might even tell it to try some wild new opening move in the next game. It literally gets smarter every single time it plays. So there you have it. We've gone all the way from a simple thermostat that just reacts to the world to a self-improving chess grandmaster. Now let's put it all together and talk about what this means for all of us.
Okay, let's do a quick recap of the entire journey. We started with the simple Reflex agent, which only reacts, but has zero memory. Then we leveled up to the model-based agent, which remembers the past, but still can't really plan ahead. From there, we got the goal-based agent, which aims for a future goal, but honestly, any old path will do. So we upgraded to the utility-based agent, which evaluates all the paths to find the absolute best one. And finally, the big one, the learning agent, which constantly improves on its own. See? Each level directly fixes the big weakness of the one before it.
But the future probably isn't about just one agent acting all by itself. It's really about teams of agents working together in what are called multi-agent systems. And this is so important. It's not about just replacing humans. The most powerful, most effective systems we have right now are the ones that keep a human in the loop, for guidance, for creativity, and for just plain old common sense. And that really leaves us with one big final thought. As these agents get more and more powerful, especially those learning agents being supercharged by generative AI, the real question isn't just what they can do on their own. It's about how we are going to work with them. Are they here to replace us, or are they here to amplify us? I think that's the big question we're all going to have to answer.